Hello everyone and welcome back to building a redstone computer with Zelda. Today we are going to hop in and start working on the storage system for this computer. Or maybe I'll fix up the problems I was having with the logic units that I was working on the last two episodes, I think. So my computer's still having some troubles right now. I've limited the frames to 40 frames a second in recording, and it's gonna vary a little bit depending on what I'm gonna do. So let's get started. I want to tell you guys what kind of things I have designed for the memory cells. Now I wrote this down on some paper when I was in school, bored of class. I wrote down some things. Let me find them. They're somewhere here. Don't worry. Okay. So I seem to have found a quick and really small, fast, and efficient way of storing memory or data values in Minecraft. It's kind of like a solid state drive or like really good RAM. So I'm going to show you. I didn't actually quite finish it. I still have the reading what line number thing isn't complete, but I think I have a pretty cool and easy idea that will hopefully fix that. So let me grab some items that I'm going to need. I'm going to need a few items. I need some, what are they called? No, it's a receiver. A transmitter. Excuse me. I'm going to need some red power logic gates, of course, to make this nice and compact and fast. And I need some redstone latches. I need some good old-fashioned vanilla repeaters. And there's a reason why I can't do this with red power computers. I mean repeaters. It's because of the lock function on the vanilla repeaters. If you oh, damn it. That's in the new snapshot, I think. Oh, that's gonna change things. I might still be able to do it with some red power stuff, though, I think. Yeah, this is gonna be different. I didn't think of that. Let me see. I could probably do it with an AND gate. Where'd the RS latch go? Did that like die? Seriously? What? Okay, I'm not going to question that. I don't even know where that went. I'll have to look over the video to see where it went. I need an AND gate, and I'm going to need something to rotate. Did you guys just see that? And wow, that's what the heck? Should I be going to Creative Plus Plus? That might be a little easier. And I just want to get that down one too much. Hopefully things aren't too loud for you guys. I need a... okay, and... what? I grabbed one, thank you very much. we got and repeater, a latch, transmitter, receiver, a lever, and transmitter, receiver. I think for now that'll do. I want to show you guys a really awesome thing. So I'm going to need a receiver here. Yeah, a receiver there. And we will set this to frequency 1 and name it clear mem. So that will clear the memory. So if I place another one down, I can just click it and it'll get it in there. That's going to reset this once I apply a value to this side. Yeah. Alright. So I was hoping on these repeaters to have the lock function, but I guess that's in the snapshot. I was playing a little bit of that and it got stuck in my head. I'll have to do something about that. Why is it 7? Okay, sorry, just looking on the screen. So we need a okay, this will be value 100. It'll be read mem, and then this will be 110, 101, and it'll be write mem. Sorry. So the AND gate, I guess I could make it work like a oh, that's what I need. I need a screwdriver. I don't think it matters. Okay, so you want the output there. Oh god. Yeah, that's right. Yeah, I think so. And then this receiver will be on read mem. Oh, wait a second. No, that'll be read mem line 1, I think. Actually, that will be in the thousands. Oh yeah, we could have a lot of memory there. So I think at 1,000 we'll do read mem ln1. So that's it, and then when that gets activated, so when line 1 gets activated, it'll output the bit because it's currently 1, and then when the reset mem for it gets activated, that's not a transmitter. So when it gets reset, it'll be reset and it will no longer output that 1 bit. This changes if it's reading from it, and I'm gonna have it so it can write in a minute. So we'll have a, so we'll do 10, we'll do by, no, 2 mem bit 1, okay, I can't copy, 2 mem bit 2 b2, and so on. 12, I guess I better do it. 2 mem b3. I won't do the last one for you guys' sake. So basically, these are the inputs for the bits. So binary bit 1, binary bit 2, binary bit 3, binary bit 4. So like 0, 1, 0, 1 or something like that. And then the write to the memory has to be activated. Then you input the signals, and then you can deactivate this. But there's a problem. You would only have 1 byte of or you'd have a 1 byte array of memory here. So you would need to have multiple of those set up to get like 3 bytes, for example, or like 16 or something like that. There is a way to get around this. I thought about that, and I decided I was going to do a kind of thing where you input your pulse, and then this is the really cool part. So basically, if the pulse is 2 ticks long, this will activate the AND gate, and then it'll send out a sing saying it wants that one to be red, I believe. Here, let me try something. I think I can. I don't even need the repeater there, but whatever. So if this is clear, that is read. We also want write, and this is gonna be confusing. I'll probably put the picture that I have on my paper up on the screen if I can remember, because this can get pretty interesting. But basically, we'll have that system, and then like see that requires a 2-tick pulse, and then like later down the line, this will require 1 tick, off 1 tick, on 1 tick, and then that would be on 1 tick, off 2 ticks, on 1 tick. So you could send kind of like binary data into here to trigger each line. So it'd be like on, off, on, and that would trigger this one. You guys will see. It'll all work. Everything will work, I promise. So for the read and write functions, this is the write area. Then we're gonna have a from memory variable. So you could send in multiple signals, and you get multiple different outputs from here. Now this is all going to make this very, very compact. As you can tell, like that little thing, instead of running redstone wire and having like little loops and stuff in this cell and this AND gate, they all save lots and lots of space, as you guys can tell. So instead of these, I think I'm just going to do this, and I'll hook this up to the AND gate, which will be on the repeaters, with the wire there, and probably should disable micro blocks because I hate them very much. Go away, go away. Okay. So we can just put one there, so they won't connect. And if we send a 2-tick pulse, this will light up. If we send anything else than a 2-tick pulse, this won't light up. Although if we send a 3-tick pulse, which we're not going to need because 111 will not be valid in reading memory, it has to be 1 1 or a 1 then certain amount of zeros then another 1. That should work, hopefully. So if I get a lever here, that was a 2-tick pulse, that was a 1-tick pulse. See, 1-tick pulses don't do anything. That's why they have the delays on the repeaters. if I was actually able to click my mouse fast enough, if I sent on, off, on in binary 1-tick pulses, this would not light up. It needs a 2-tick pulse, and that's the only thing that will light it up. But that'll be computer controlled, so like redstone controlled. But this is how I'm going to set up my memory, and it'll make a lot more sense. I don't even want it there. I want it somewhere back there. Once again, I have this written down somewhere. I have the whole thing planned out. Here it is. I want the RAM in the left middle of the back of the user interface. So right about there, I want it. Yes, because I'll have the add, subtract, multiply, and divide units up front. I'll have the RAM behind those. Then I'll have the solid state drive behind that for permanent storage. Then I'll have the graphics driver, and they'll all they will all wirelessly connect to the user interface. And I also have a smarter thing. See this bundle of cable? I'll hook it up to this computer. This is how we're gonna read different bits. Where are my lovely wires? So I'll have white, 2, 3, 4, 5, 6, 7, just the 8 different colors. Wait a second. Where's white? Oh. Okay, so that's 8. So here's something it'll be. It'll be like white here, orange, magenta, and so on. That'll be like bit 1, bit 2, bit 3, and it'll all come out of this computer. So we can read and set bits into these wires and have them go on to further redstone. It'll be easier for outputting data instead of having to have like that computer wirelessly connected to like 8 different computers output each one bit. It's a total waste of resources and efficiency, as it would be slow and more physical computer demanding. So let me just get rid of these guys. I might speed up the building of the memory a bit, so you guys don't have to watch me so much. So here it goes. Alright guys, I am back, and this is 4 bits of memory. Yes, it's a little bit bigger than I anticipated. But I didn't really plan for how the redstone would work in my drawing. Yeah. I think if I had those, what's they called? These repeaters in the lock mode in the new Minecraft update, then I would be able to probably reduce the size in half. But right now it has to have these extra 2 blocks of area. Not too bad. It's still pretty compact. I mean, this is 4 bits of data. 4 bits. It's a pretty decent sized space, and of course you could stack it that way, and all the way up. And I think I'll get quite a few of these. Now I'm not sure if I can get world edit on here and just like copy this and stack it in the different directions, if it'll copy the blocks right, or if I have to do it manually. Because if I have to do it manually, I'll probably only put like 8 bytes of data in there for the RAM, I think. Yeah. Oh well. Might as well show you how this works. So we have our 4 inputs that'll come from an area, and as you can see, our outputs are off, and this is empty because when we flip this, nothing comes out the outputs. This is the clear. This clears the memory, and this button writes to the memory. So what these are, this is bit 1, 2, 3, and 4. I'll turn on 1, 3, and 4, and then I write them, and I can turn them off because I don't need them anymore. And then I can read them as many times as I please with this lovely lever here. As you can see, the response time is probably about 2 ticks. I don't know. I'll have to calculate it. But as you can see, if this you have data in there because it's like 1011, and I could clear them with that. And now if I try to read, it's just 0000 because there's no data in it. And that is basically 4 bits of RAM. I want to put another 4 bits here to make it a byte of RAM, which is what my computer will be running on. It'll be running on a byte of like 8 bits of data, because we'll have all kinds of numbers and letters, so we're gonna need all that extra room to carry that stuff in binary, which is going to be a little bit complicated, but it should work. So I guess that's it for today. I kinda have a few things to do, but I'll get this processed and put up to YouTube for you guys to enjoy. And I hope you guys try to build a computer with me. And if you guys find any nice suggestions, please suggest them in the comment area below. And I will probably either use them or tell you why they would not be good, or tell you why they'd be good and why I'm not using them, or anything else. So I guess I'll see you guys next time. Take it easy.